worked. It's probably not too hard to turn it into a hash table, and you can verify it with the linear search for a while to make sure everything's sane. So that's doable. I may or may not get to that. I don't know. We'll see. Thoughts on PatchGuard. So I mentioned that PatchGuard actually enables a break of, or ShadowWalker to completely break PatchGuard, which is interesting. But first I want to kind of rant a little bit. I don't know. I don't think PatchGuard is the right approach, at least not the mandatory way that's being going about now. Unless things have changed, as far as I understand it, you need a kernel debugger attached in order to disable it. Possibly booting into safe mode, possibly not. I don't have x64 hardware, so I haven't been able to verify any of this. But it's basically going to lock out all custom kernel modifications. Anybody who wants to play with their kernel, and third-party scanners as well who want to hook system calls. Microsoft basically declared war on the good guys and the bad guys, I think, with this move. People who want to understand the kernel for drivers or whatever, who want to use the kernel for reversing other programs, or who want to do malware research to try and research which system calls malware makes, or who want to do the same thing with botnet research to try and see if they can detect, botnet infections or whatever, or the same war. And then, reversing, as I said, all these people, they're all going to look for breaks, including the bad guys, and yet legitimate antivirus is locked out. So it creates sort of a monoculture solution where you really need, it's just break once, break everywhere, one thing that you have to worry about. Instead of userland where there's multiple AV products and that malware writers would have to circumvent, now you just have one to break. And the result of this is going to be a stability nightmare. All these machines are going to, they're going to be suffering from breaks. They're going to be bug checking all over the place. I don't know. We'll see. Time will tell on that one. But in any event, it turns out that this thing does provide a way to cloak your page fault handler, which in the case of ShadowWalker means that you cloak everything. Basically, the idea, if you've read the uninformed.org paper on PatchGuard, they do have another break. This one is different from that. That was also very excellent work, very brilliant work by those guys. Very impressive. That's where I basically got this idea, since I don't have 64-bit hardware. Basically read their paper and thought of this. So the idea is you mark the start point, which is the default handler. PatchGuard, at least the version they looked at, used the default handler to start things off. It had some moduli that it checked for. There was special random value, and that scan. So you mark that non-executable, which is supported on your 64-bit CPUs. And then in your page fault handler, if your instruction pointer is equal to that default handler when it first starts, you prime your data table with a fake page fault handler copy that conceals your jump or whatever in the real page fault handler. And then you're gone. You should be ghost. This PatchGuard will continue to scan, and it'll read use the there shouldn't be a context switch, and then you should be gone. Now, I could be wrong about this. Obviously, I haven't tested it, and there may be ways around it, but, kind of short on time. Don't really like the system. Next slide, please. Yeah. Wait, I do that myself. All right. Okay, so ADHD. So ADHD is a nice little graphic from the movie. Also, side note, probably another DMCA violation with these slides. Probably may or may not be fair use to use these images. I'm kind of going a bit overboard, but all you have to do is use NPlayer to play that DVD, and then you've got another DMCA violation, which is kind of nice. All right, so ADHD debugger detection. A few ways that a debugger can be detected on Windows. You have the process block that has a special flag being debugged that can be modified from userland to spoof. There's also a couple of library calls that check it. I believe they're both. The first one is a library call, and the second one I believe is a kernel call. But it can also be checked with a couple of lines of assembly. So hooking the kernel for this is not really an option, but you can bang out of land. Query information process is a system call. You query with a debug port property, and if it's non-zero, then you've got a debugger attached to that process. Otherwise, you don't. This one is really clever. There's this khaki-wares utility that sets a little bit of a jump in these two break-ins that are used for thread break-in. When you attach a debugger, it'll jump and alert it. And then you can check the parent key, and this last one will allow you to prevent exceptions from being delivered to a thread. It doesn't really hide the thread per se. It just prevents exceptions from being delivered to the debugger for that thread. You've also got a couple other basic ones, more general. Again, that breakpoint verification or exception raising. You also have wall clock time, and you can check the window titles and running as well. So what does ADHD do about all this? ADHD resets that PEB flag. It zeroes the debug port. It protects the debug break-in from hooks. It restores them if it detects modifications. It does defeat khaki-wares anti-debug. Resets the parent PID if you've launched your process in a debugger to Explorer. It blocks thread high from debugger. There's no way to check to see if thread high from debugger actually succeeded, really, as long as you're being delivered. So just denying that thing outright just seems to be okay. ADHD it does have some weaknesses. The exception redelivery isn't handled. Basically, all your exceptions need to be redelivered by your user land debugger. IDA can do this for most exceptions. Also, time is an issue. Can't really hook those. They're done with shared memory now, probably for perf or timer resolution issues. There's a shared page between kernel and user that has the timing information that these guys actually read in most cases. So you can script your debugger. You can use clue or whatever for trace points. Also, there's no process and title cloaking, but you can use Futo, and the debugger plugin, IDA debugger plugin clue will do this as well. Will spoof your titles. So librootkit, for those of you familiar with the movie Sark, and he's staring at what appears to be the kernel over there, I guess, and Pac-Man for some reason. He's running through the system, having some fun. Maybe that's what annoys him. I don't know. All right, so noteworthy librootkit APIs. Basically, we've got you can hook a syscall. Platform OS independent with a name based on this guy Gareth had a rootkit.com post for something like this. I cleaned up the interface, made it a little. Also, there's setup hot patch, which works kind of like detours. You basically give it a function you want to patch, a thing to jump to, a buffer to contain the resulting assembly to set up the jump back that you call from your target when you're done, and then the length of this. And it uses this guy Nick Cappen's x86 length decoder, very nice length decoder, very very minimal, and it's also used by swap context, and there's an undo for this thing as well. And then these guys at the bottom, TV borrowing and channel table finding and setting interrupt vector or whatever. This TV borrowing is useful for looking up or for getting a user land pointer to give the system calls you want to execute from the kernel. Clue is the IDA plugin. I think this graphic is kind of nice. This guy basically hooks your IDA is an IDA debugger plugin to set hidden software breakpoints with Tron. So you can set. So it's useful. So you don't have to just set your 4 hardware breakpoints and worry about those and have to continually reset them. You can set as many hidden breakpoints now as you want. I haven't tried tracing yet though. It's on the to-do list. Probably it should work. The IDA plugin API is unfortunately broken. There's 4 calls: add breakpoint, delete breakpoint, read memory, write memory, and a few others. But it never calls write memory. So had to use Microsoft detours to detour write process memory in order to hook it and do the writing to hidden memory to set the breakpoint. And it changes the IDA of Windows titles to random strings, kind of a little trick just to avoid detection. The warden, I believe, checks your window titles. as a form of detection for debuggers. So, talk setup. So first we tried to make the orange anonymous, and then once we made the orange anonymous, then we knew it was ready for a person. All right, that's it. No. So there's several components that went into this. And the first, on this side, we've got a ventriloquist client. We've got a voice changer, which is why I sound like some kind of elf. It's not actually my real voice. We've got a VNC client as well for the connection to the virtual machine, and Tor, of course, to route everything over and make to obfuscate the IP address. So there's also a Linksys router involved, basically for a firewall and a little bit of range for 802.11. It could have just as easily been done with another VM on this side and a Linux host, or as we'll talk about in a bit, a complete Linux solution. And then a VM image to make things easier on Hikari, who was extremely helpful in setting this up. Of course, the whole con couldn't happen without this guy, and definitely this talk would not have happened without his patience with my random emails and insane demands. Props to him, and he's on the side is a VM image with a VNC server, some tools, and the slides, and Ventrilo server and client for voice. And then lastly, plenty of paranoia and fuck the man. These are both necessary components for this talk. All right, so local setup. 802.11, if you want to roll with that, you'll find a coffee shop, hotspot, friend's apartment with open access point, whatever. Change the MAC address on or your laptop, and put the thing in the client mode, supported by OpenWRT, VDWRT. Ventrilo has some UDP traffic that needs to be blocked. That's a reason for the Linksys or a Linux router ahead of you or whatever. And it also phones home, so you want to block that. So you basically want to block all but your Tor server traffic at the Linksys router. You want to, and then these two IP cables will do that. And then you need to configure your Tor RC a little bit so to build fast circuits to Tor, so you're not depending on just chaos to be able to get you a good link to wherever. And then then we add a tunnel VNC and Ventrilo over SSH-L. And there's a little echo script that lets me know that this thing is still live. That's printing out times as well. Okay, so here's the setup diagram of all this works. There's only one Tor circuit needed because we're actually multiplexing VNC and over SSH here. Because this is done both to make it easier for the Tor circuit and because they don't support proxy, so they think they're connecting to the local server. Also, in the event that data retention actually happens and is competent, which is a big if, there may or may not be a global adversary in the future, in which case you'll probably need to do some extra sketchiness, make sure this 802.11 network is not close to you, or additional fake flows with some of your friends into the Tor network. The big issue with the global adversary is that this talk is happening at a specific time. It has a relatively guessable traffic pattern, and it is going for a specific duration. This is very fragile to someone who's able to observe, say, the Backbone or Dan Kaminsky, for example. It could really ruin my day. So you have, on the other side, you have EVDO,